Namaste, welcome back to Sitapragna channel. You are watching Machine Learning Basics Theory playlist. And today we are going to learn about reinforcement learning. So what is this exactly? Reinforcement learning or RL is a type of machine learning where an agent learns to make decisions by performing actions in an environment to maximize cumulative rewards. Unlike supervised learning, where the model learns from a fixed data set with labeled examples, reinforcement learning involves learning through trial and error, with the agent receiving feedback in the form of rewards or penalties based on the actions it takes. This you will understand more when I gave you an example or where it is actually used. You will be like, oh, makes sense. What are the key concepts in reinforcement learning? First, as I said, there will be an agent, the learner or decision maker that interacts with the environment. And then you actually have the environment, the external system with which the agent interacts, receiving states and rewards based on its actions. And then you have something called state, which is a representation of the current situation or condition in the environment. And action, which is a decision or move made by the agent that affects the state of environment. And reward, which is a feedback received by the agent after taking an action. It can be positive, which is a reward, or negative, which is a penalty. And policy, a strategy or mapping from states to actions that the agent uses to decide which action to take in each state. And value function, a function that estimates the expected cumulative reward for each state or state action pair, helping the agent evaluate the potential benefits of actions. And finally, exploration versus exploitation. The dilemma between exploring new actions to discover their effects and exploiting known actions that yield high rewards. And remember, there is already a video that is provided in the description, which is about reinforcement learning. You can learn it there. And we have done a couple of projects using reinforcement learning technique as well. So if you haven't watched, go check it. And the links are in the descriptions, by the way. So those are some key concepts, random words. You won't understand them until we jump into an example. But how does this work? So you have the first thing, interaction. So the agent interacts with the environment by taking actions in different states. What are those actions? Again, it depends on where you are using in reinforcement learning. You will learn in our scenario-based step-by-step explanation. And after each action, the environment responds by transitioning to a new state and providing a reward to the agent. Okay. The agent's goal is to learn a policy that maximizes the cumulative reward over time. To do this, the agent evaluates the outcomes of its actions and adjusts its policies accordingly. The agent uses algorithms like Q-learning, deep Q networks to update its value function or policy based on the rewards it receives. The agent continuously interacts with the environment, receiving feedback, as I said, rewards or penalties, and refining its policy to improve future decisions. Over time, the agent learns to take actions that lead to higher cumulative rewards, effectively mastering the task. Now, that might sound alien to you, but when you look at real-time examples, you will be like, oh, this is what being used in these situations. Yeah, you will say that, trust me. Now, the first real-life example is game playing. Everyone might have played. For example, let's say chess, Go, or video games, any video game for that matter, right? Why? Any video game, you might have played video games. You might have seen AI in the games, right? So you will be playing against AI or NPC sometimes. They are nothing but agents. Okay. An AI agent learns to play a game like chess or Go, where the objective is to win against an opponent by making strategic moves. So the agent's goal is to win against us. How does it work? The current position of the pieces are placed on the board. The move the agent decides to make, for example, moving a pawn or capturing an opponent's piece. Positive rewards for capturing pieces, controlling the board, or winning the game. Negative rewards for losing pieces or losing the game. The agent starts with no knowledge of the game and learns by playing many games, receiving rewards or penalties based on the outcomes of its actions. Over time, the agent learns to play the game at a high level, often surpassing human expertise. For example, AlphaGo beating the world champion in Go. Do you imagine that? Then another use case is autonomous vehicles. An autonomous vehicle learns to navigate and drive safely on roads by interacting with the environment and making real-time decisions. Okay, the current situation of the vehicle, including its speed, position, and surrounding objects. Example, other cars, pedestrians, traffic signals. Decisions like accelerating, braking, turning, or changing lanes, these are called actions. And the reward, positive rewards for staying in the lane, following traffic rules, reaching the destination safely. Negative rewards for collisions, sudden braking, or violating traffic rules. The vehicle learns through simulation and real world driving, improving its driving policy based on feedback from the environment. And the outcome is the vehicle becomes proficient in driving, making safe and efficient decisions in various traffic conditions. And next example is robotics. You might have already guessed it. Scenario, a robot arm learns to pick up objects and place them in specific locations, such as on an assembly line or in a warehouse. How does it work? State, the current position of the robot arm and the objects it interacts with. Action, movements of the robot arm, such as extending, rotating, gripping. Rewards, positive rewards for successful picking up and placing objects. Negative rewards for dropping objects or taking inefficient paths. The robot arm starts with basic movements and gradually learns to optimize its actions to perform tasks more accurately and efficiently. And the outcome, the robot arm can perform complex tasks autonomously, improving productivity in industrial settings. And then personalized recommendations. A recommendation system learns to suggest content like movie, videos, articles that a user is likely to enjoy based on their interaction history, like Netflix or YouTube. What is the state here? The current user profile, including their viewing history and preferences. And the action, the recommendation system suggests content for the user to watch or read. And the reward, positive rewards if the user engages with the content. Example, watches the video or rates it highly. Negative rewards if the user skips the content or gives it a low rating. The system continuously learns from user interactions, refining its recommendations to increase user satisfaction. And the outcome, the system provides increasingly personalized and relevant recommendation, enhancing user experience and engagement. You might be seeing this running reinforcement learning running behind the scenes all the time on Netflix and YouTube because the recommendations it always changes. It is dynamic. And final example, financial trading. An algorithm learns to trade stocks, currencies, other financial instruments by interacting with the market and making buy or sell decisions. And the state, the current market conditions, including prices, trends, and economic indicators. Action, the decision to buy, sell, or hold a financial instrument. Positive rewards for profitable trades, negative rewards for losses. The algorithm learns from historical data and live market interactions, refining its strategy to maximize returns. The trading algorithm becomes more effective at identifying profitable opportunities and managing risks in the market. So those are some examples, and most of them you might have already seen, like the playing games, financial recommendations, etc. So what are the advantages though? The autonomy. RL agents can learn to perform complex tasks autonomously without needing explicit instructions for every possible situation. And adaptability. RL can adapt to dynamic environments, making it suitable for applications like robotics, autonomous vehicles, real-time strategy games. And think about it, I wouldn't think, when you send a particular robot to different planets, right? Maybe you can train them here in a simulation-based environment where it can adapt automatically after going on to the different planets, correct? That there might be one example. I'm just throwing it out there. I don't even know. And long-term decision making. RL focuses or considers the long-term cumulative rewards of actions, making it efficient for tasks where short-term decisions impact long-term outcomes. Challenges. Exploration versus exploitation, right? Balancing the need to explore new actions with the need to exploit known rewards is a key challenge in reinforcement learning. And RL can require significant computational power, especially in complex environments or when using deep reinforcement learning. Designing an appropriate reward structure is crucial for guiding the agent towards desirable behavior. Poorly designed rewards can lead to suboptimal or unintended outcomes. And before jumping into the summary, let's go to our scenario based step by step explanation of this one. And the example we are going to pick is game playing. Of course, game playing. I am a gamer myself, so what other example than game playing? Imagine you are developing an AI agent that can learn to play a game like chess, Go, or a video game, for example, Atari. The objective is to teach the agent how to make the best possible moves to win the game against an opponent. This process of learning to play the game through trial and error, receiving feedback in the form of rewards or penalties, is a classic example of RL. If you are a programmer, you might have already coded tic-tac-toe game and etc. Okay, but that it randomly picks, you might not have created an agent etc, where it learns as as the game progresses. Whatever you wrote, whether it is Python, Java, it doesn't learn anything. It will repeat the same thing again and again. But the difference here, if you did it using tic-tac-toe, using um, reinforcement learning, is it will learn based on the previous game and it will improve itself. Got it? So that's an example. So understanding the problem here. The goal is to train an AI agent to play a game effectively, maximizing its chances of winning by learning which moves lead to the highest rewards. And the type of problem is sequential decision making problem, where the agent must choose a series of actions or moves that will maximize its cumulative reward over the course of the game. Okay, and we said agent. Agent is the AI player that learns to play the game. And what is the environment here? The game itself, including the rules, board pieces, and opponent, and the state, the current situation or configuration of the game. For example, in chess, the state includes the position of all the pieces on the board, white and black on opposite side, placed in the appropriate positions. And the action is a move that the agent can make. In chess, this could be moving a pawn, knight, or any other piece. Reward, feedback received after taking an action. Positive rewards might be given for capturing an opponent's piece, while negative rewards might be given for losing a piece or making a bad move. And policy, the strategy that the agent uses to decide which action to take in each state. The policy is what the agent learns and improves over time. Correct? And the value function, which is a function that estimates the expected cumulative reward from each state or state action pair, helping the agent evaluate the long-term benefits of its actions. But how does this learning process work? Okay, step one, initial interaction. The agent starts with little or no knowledge of the game, assuming this is his first game. It begins by taking random actions to explore the different states of the game and learn the consequences of those actions. Okay, step one is initial interaction. Okay, step two would be receiving feedback. After each move, the game transitions to a new state and the agent receives a reward. For example, positive reward, let's say +1 for capturing an opponent's piece, -1 for losing a piece, +10 for winning the game, -10 for losing the game. Okay, and step 3, updating the policy. The agent uses the feedback to update its policy and value function. Algorithms like Q-learning or deep Q networks are commonly used for this purpose. The agent learns which actions tend to lead to better outcomes like higher rewards and adjusts its strategies to favor those actions in the future. And then step 4, exploration versus exploitation. Okay. The agent faces a trade-off between exploring new actions that it hadn't tried before, which is the exploration part, and exploiting known actions that have already yielding good results, exploitation. So it is very hard, right? Don't you think so? Initially, the agent might explore more to learn about the game, but over time, it focuses more on exploiting the actions that lead to the highest rewards. And step 5 is continuous improvement. Actually, don't you think this is like this applies to us humans as well, right? Yeah. Whenever you are learning something, stepping into something, you don't have any idea of it. Then, based on what you do, whether it is positive, negative, you will receive feedback and then you will update your mindset. Okay, so this is positive, this is what I need to do in my life to get better rewards. Negative, don't. And then you will have exploration like, do I have to learn new things or just upgrade myself on the things that I already know, and then continuous improvement. Don't you think? Maybe they designed this based on, our real life. Well, that's me thinking. The agent plays many games, continually refining its policy and improving its performance. Over time, it learns to make more strategic moves, better anticipating the opponent's actions and maximizing its chances of winning. Same applies to our life as well. We need to continuously improve ourselves. Nowhere in our life one can say like I am perfect. I am a master of this. No, there is no such person as he knows everything, he does everything, and etc. We have so many things to learn in this particular life. Nobody knows everything. Okay. Some people in the comments say like, oh, you know a lot of stuff. No, I wouldn't agree with that. I myself improving every day, you know, by learning new things. Sometimes some people will leave some comments saying like this is this. Then I'm like, oh, that is correct. I don't know. I didn't see it in this way. So I learn from you as well, from you guys as well. So don't forget to comment whenever you think there is a better way to learn something or better way to explain something. It's not just me teaching you. I would like you to teach me as well with whatever you know. Okay, so the example in our case, the current board position, which we already know and we already discussed about this, and the agent starts by making random moves. It might lose many games at first, just like our real life. We might we might learn so many things, so many failures, right? That's why they says failures are stepping stones to success. There is a reason why they said that. You fail, but you should not get discouraged because you are learning important things from it. There is a saying like none of the successful people in this world succeeded all the time. Okay, they are in that position after losing so many times. Correct. I think the good example they give is Abraham Lincoln, right? I think he lost in elections like in 11 times before becoming the president. If he got discouraged the first time he failed, he wouldn't have become the president. So never get discouraged by failures. Just take the good things from that failure and use them, next time you try something else. So that's how it should be always. Remember, it might, even this agent might lose many games at first, but it gradually learns which moves are beneficial. Correct. Example, controlling the center of the board, protecting key pieces. As the agent plays more games, it refines its strategy, learning to set up traps, defend against attacks, and eventually win games against increasingly stronger opponents. And the outcome, after many iterations, the agent becomes proficient at chess, capable of competing at a high level. It has learned to anticipate the opponent moves, control the board, and plan several moves ahead to secure victory. And in real life, the one suggestion I always give is, see, by default we don't know everything, but once you learn something, don't try to make, let's say you failed, don't try to repeat the same thing. That's my motto in my life. If you already did a mistake, don't try to repeat it again. Try to avoid it. Okay. And then next, once all this is done, evaluating. How do you evaluate the agent's performance? The proportion of games the agent wins over time. As the agent learns, its winning rate should increase, and the total reward accumulated across games. A higher cumulative reward indicates that the agent is making better decisions overall. And also observing how the agent plays the game, such as its ability to make strategic decisions, defend against attacks, and exploit the opponent's weaknesses. These are some ways to evaluate the agent's performance. And again, these go beyond game playing. We already discussed some of the real-time examples. Okay, so that's about this scenario. And if you have to go through the summary, RL enables agents to learn from their interactions with the environment, maximizing cumulative rewards over time. Applies to autonomous vehicles as well. RL has shown success in areas like game playing and all those things that we already discussed. Despite its challenges, RL remains a powerful and evolving field in AI and machine learning. If you are interested in AI, then now you know one player that you need to be aware of. So that's about reinforcement learning. I hope you enjoyed it. If you did, don't forget to subscribe, like, and comment. Like and comment is a must. That will really help this channel and videos reach wider audience. So please help me by doing that. And thank you for spending your time, and see you in the next video. Have a great day. Peace out.